All right, and here we are again with volume of spheres and cones with me. That's Mr. Hain. And this is page 3 if you're keeping up with me in my classes. And for those of you playing along at home, it's still that simple too. You can just play along at home. All right, so how can I find the volume of spheres and cones is my essential question. And we're going to be modeling problems with math. All right, so let's do an example really quickly. And this should be fairly straightforward. In my classes, I'm going to do a deeper investigation about how this works, but the nuts and bolts of it are exactly the same. The key thing here is the formula. The volume of a cone is pi, or we use 3.14, times the radius squared times the height divided by 3. The short version is if I draw a cylinder that is the same height as the cone occupies 1/3 of the volume of the cylinder. So that's how we take the formula for the volume of a cylinder and divide it by 3. Sweet. So let's just take a look at this one. So my radius is 2, my height is 7. Plug it into the equation, and then into my calculator, and kaboom, skadoosh, whatever you want to say. 29.3 feet cubed. And again, I'm going to make a big deal out of this. It is cubed because we are in 3 dimensions. We are measuring length, width, and height. All right, cool. If you don't have this, pause the video. Make sure that this is written in your notes. This is the only time you're going to see the formula for the volume of a cone. The rest of the slides, we're going to be asking you to apply it. If you unpause the video, then we're ready to go. All right, it's your turn. So I've got 4 problems on this slide and 2 problems on the next. I think the biggest piece to remember is that if you're given the diameter, divide it by 2 to find the radius prior to finding the volume for all of these cones. So go ahead and pause the video. What I'm going to encourage a classroom to do if you're using this video is to have students solve this on their own using the formula that they already have written. Once the work is on the board, then go ahead and unpause the video to check your answers. All right. I'll be back when your students are done, or when you at home are done with your work. All right, we're back. And here we go. We got a radius of 5 because it gives us the diameter and a height of 9. Plug it into the formula and skadoosh. There you go. For B, they give us the radius, which is 14, and the height, which is 2. Plug it into the formula and we have our volume. For C, they give us the, did you just say diameter? That's right. The radius is 45, the height is 35. Plug it into the formula, and you have your volume. Don't get scared of large numbers, people. Numbers can be gigantic. For D, they do give you the diameter. So you have to divide that by 2. Radius is 5, height is 14. Plug it into the formula. Okay, that's going to get really old, so I'm going to stop doing that. The volume is 366.3 centimeters cubed. Notice that each of these are cubed. Again, that's something that I pick on in my classes because you're dealing with length, width, and height. You're 3-dimensional figures, and you're finding the volume. You're measuring a 3-dimensional space, so that's why it is cubed. All right. All right, so I have 2 other application problems. I kind of stripped everything down to the bare bones. So go ahead and, yes, I'm not going to sing it again. Plug into the formula. Pause the video, have your students or you at home work these out, and I'll be back in a moment to check your answers. All right, E and F. Here are the volumes you have for E and F. Again, don't be scared of large numbers. Once we get to spheres, these numbers are going to get ginormous. All right, don't get scared. All right, I hope you got those. If not, go back to the example worked problem number 1 at the beginning of this video. Sweet. All right, so I combine volume of spheres in with this lesson as well. 2 and 3 I'm going to walk through slowly as worked examples. So you see my formula has changed. It is 4 times pi, or 3.14, times the radius cubed, because now that radius measures 3 different directions, divided by 3. There are a few really great videos on YouTube explaining the formula and using CAD and computer graphics that are beyond my expertise. I highly suggest you use those to see how that formula is derived. But until then, let's work through these examples. So for number 2, we have a radius of 23. and I'm going to plug it into the formula, and you see that I have 23 cubed. Now this is going to give me a big answer even though I divide my answer by 3, because cubing a number, that's 23 times 23 times 23, that is a huge number. So I have over 50,000, almost 51,000 feet cubed. Okay, so for number 3, it's the same figure. It's a sphere, but you see that it's half a sphere. So I find the volume of the sphere, which is 463, but because it's half a sphere, I divide my answer, 463, by 2. So dividing it in half gets me 231.5 millimeters cubed. And that's just, again, because this is half a sphere. All right, if this is happening in a classroom, go ahead and pause the video here. Make sure all the students have this in their notes before moving on, and we have some you try it examples after this. And we are back for the your turn examples. I promised you guys I wouldn't sing. I'm sorry I broke my promise. It's just too much fun for me to do it. All right, so go ahead and pause these. Again, I suggest that if this is in a classroom, that you call on your students different ones to make sure that they have plugged this into the formula and have the correct answers prior to moving on and checking them. Have the students check with each other. That's what I do. All right, here we go. I'll pause. Go ahead and pause the video. I can't pause it, and I'll be back when your students are done. Or mine. And we're back. So remember I told you guys not to be scared of large numbers, and we have answers in the millions, and that is not a big deal. So I hope that you have these by plugging them into the formula correctly. Again, there are a lot of explorations on YouTube that I cannot reproduce because they use computer graphics that explain these formulas in greater depth, especially the volume of a sphere, so make sure you take a look at those if you want some more examples of why the formula looks the way you do. And if you're in my class, go ahead and write your summary and make sure your table of contents is updated. And until next time, ladies and gentlemen, keep doing the math.